For decades, the idea of flying cars belonged to the world of science fiction. Movies imagined cities filled with vehicles moving effortlessly through the sky, while engineers around the world struggled to turn those visions into reality. Most projects never made it beyond the concept stage. Some were too expensive, others were too complex, and many simply failed to convince people that flying transportation could ever become practical for everyday use. Yet while much of the world continued debating whether flying cars would ever become a reality, something extraordinary was quietly taking shape in China. At a massive manufacturing facility in Guangzhou, engineers and designers were working on a project unlike anything seen before. It was not simply another electric vehicle. It was not just an aircraft. Instead, it was a completely new transportation system designed to bridge the gap between roads and skies. The project became known as the land aircraft carrier. Unlike futuristic concepts that exist only in promotional videos and computer-generated images, this machine was designed with a clear goal: real-world deployment. Commercial deliveries are expected to begin in 2026, marking what could become one of the most significant milestones in the history of personal transportation. The company behind this ambitious vision is Xpeng Aero HT, a division of the Chinese electric vehicle manufacturer Xpeng. Over the past several years, the company has invested heavily in advanced mobility technologies, believing that the future of transportation extends far beyond traditional roads. Before unveiling the land aircraft carrier, Xpeng Aero HT introduced a groundbreaking aircraft known as the Xpeng X2. At first glance, the X2 looked like something taken directly from the future. Compact, lightweight, and powered entirely by electricity, it represented a new generation of aircraft known as eVTOLs, short for electric vertical takeoff and landing vehicles. Unlike conventional airplanes that require long runways, eVTOL aircraft can take off and land vertically. This allows them to operate in areas where traditional aircraft simply cannot. The Xpeng X2 quickly attracted international attention. Demonstrations showcased its ability to fly autonomously while carrying passengers through carefully controlled environments. For many observers, it was proof that the future of personal air mobility was no longer a distant dream. But the true significance of the X2 was not its appearance. It was the engineering hidden beneath its lightweight frame. Constructed using advanced carbon fiber materials and aerospace-grade aluminum alloys, the aircraft was designed to maximize strength while minimizing weight. Every component was carefully optimized to improve efficiency, performance, and safety. Power came from 8 independent electric motors, arranged in an octocopter configuration. This setup provided an important advantage: redundancy. In traditional aircraft, engine failure can create serious risks. In the X2, however, multiple motors work together to maintain stability. If one motor experiences a problem, onboard systems can immediately adjust power distribution across the remaining motors, helping maintain controlled flight. This focus on safety reflected a broader philosophy guiding the entire project. The goal was not merely to create an impressive flying machine. The goal was to build a transportation platform capable of earning public trust. As development continued, engineers faced a critical question. Even if personal aircraft became practical, where would people store them? How would they transport them through crowded urban environments? And how could flying vehicles be integrated into existing transportation infrastructure? The answer led to the creation of the land aircraft carrier. Rather than designing a standalone aircraft, Xpeng Aero HT developed a modular transportation system consisting of 2 integrated components. The first component is a large 6-wheel electric vehicle. At first glance, it resembles a futuristic truck. However, beneath its bold exterior lies a highly advanced mobility platform. Equipped with a powerful electric drivetrain and sophisticated steering systems, the vehicle is capable of navigating complex urban environments while carrying a unique cargo. Hidden inside the vehicle is the second component, a compact passenger aircraft. When needed, the aircraft can be deployed from the rear section of the carrier vehicle. Within minutes, the system transforms from a road-going electric vehicle into a personal air mobility solution. This approach solves one of the biggest challenges facing the flying car industry: Instead of forcing owners to choose between driving and flying, the land aircraft carrier allows them to do both. The concept is surprisingly practical. A user could drive through city streets, reach an appropriate launch location, deploy the aircraft, complete part of the journey through the air, and then continue on the ground after landing. Such flexibility has the potential to redefine how people think about transportation. More importantly, it demonstrates that the future may not belong to flying cars alone. Instead, the future could belong to hybrid mobility systems that combine the strengths of both ground and air transportation. As governments, regulators, and technology companies continue exploring the possibilities of low-altitude air mobility, projects like the land aircraft carrier offer a glimpse into what tomorrow's transportation networks might look like. The question is no longer whether personal flight is possible. The question is how quickly it can become part of everyday life. And if the engineers in Guangzhou are successful, that future may arrive much sooner than anyone expected.